good morning, good afternoon, good evening, and good night. Good afternoon for all the lecturers and all the audiences. Today we are Group 6 from the course Quantitative Modeling will be presenting our final project that is titled Delivery Route Optimization for Horeca Segment B2B for Surabaya, for Kemayoran Surabaya using linear programming. And our group consists of 4 people. The first one is me, Ayu Olivia.
Dan me, Maulana Ahmad Fahrezi.
Mokhtam Roya Zidan.
And me, Ryan Rapadi Purnomo.
So here is the background. So in the business, or we can call it B2B. This is a fresh products industry. This delivery efficiency plays a critical role in ensuring customer satisfaction and product quality, especially when dealing with goods like vegetables and fruits like that. Kemayur is a local supplier of fresh produce, serves various in Horeca, or we can call it as hotel, restaurant, and cafe. So it is essential to develop an efficient delivery and routing system that can optimize routes and meet all operational constraints. Next. So here is the company profile. So the Kemayur Fresh Food, it is located in Surabaya. That distribute fresh food products, vegetables, mainly to hotel, restaurant, and cafe, and also retail to the business in Surabaya. The service offered is consists of three. The first one is daily direct delivery. Then the second one is online ordering via apps, and then the last one is the competitive pricing with guaranteed freshness. And the address is in Tegal Sari, Surabaya. Next.
So our objective is to identify the most efficient delivery routes for vegetables from Surabaya to hotel, restaurant, and cafes. And the second one is to use mathematical methods like linear programming or integer programming. The third one is to minimize delivery distance, travel time, and cost. Next, the impact we're aiming for provide a basic understanding of how quantitative methods can improve logistics. The second one is to help improve efficiency in delivering products to the hotel, restaurant, and cafeteria segment. And the last one is to serve as foundation for building smarter, cost-efficient distribution strategies. Next.
Next, we move to the data collection method. Data collection data that we collect. Firstly is about delivering scheduling from Monday to Friday. The next is the customer destination, which is for the deadline delivery 8 a.m. is hospitals, and for 10 a.m. is to Tongi Cafe and Hotel Papilio. The third is vehicle use. The company only use Astara with multi-drop less than 50 kilogram. And then after that, we have expenses with budget 10,000 with tariff approximately 5,000 per day. Next. So we next explain to the flow chart about the how the company is optimize the delivery route, which is start from the delivery any factor like delivery points, and then we use LP model, and the output is the minimum distance and cost evaluation. Next.
So this is diagram models, transportation network used for planning delivery distribution routes. The O is a center hook, Kemayoran, Surabaya, and there we have Husada Utama Hospital, Gotong Royong Hospital, Tongi Cafe, and Hotel Papilio. Next. Yeah. So we designed three delivery scenarios, 2 client per trip from Kemayoran Surabaya based on real distance from Google Maps, as we can see here. All right, just next.
Okay, based on the data we collected and the problem formulation we made, we resolved this using a Microsoft Excel solver. a symmetric matrix was created representing the travel distances in kilometer, given all the delivery nodes. Depot RS Udara Utama, RS Gotong and Tommy Cafe Hotel Papilio. And the general values are set to 0 and other distances are filled using Google Maps data. And here is the binary variable table that is constructed where the 1 indicates a selected route from node I to node J, and 0 indicates that the route is not selected. And each row represents origin nodes, and each column represents destination nodes. And the total distance, which is Z, is calculated using the sum product formula, which minimizes Z, where Cij is the binary decision variable and Xij is the distance between nodes I and J. And from the result, we get the optimal total distance is 48.5 kilometers. And here's how we formulate the solver in the Microsoft Excel. We set the objective, we changing the variable cells, and we set the constraints, and finally the solving method. The optimal delivery sequence is reflected by the selected routes, indicated by the first in the decision table. The routes chosen are depot from RS Husada Utama 7.5 kilometers, RS Husada Utama from to RSGR is 12 kilometers, RSGR from Tongji is 30 kilometers, and Tongji to hotel is 8.5 kilometers, hotel to depot is 7.5 kilometers, and the total distance will be the 48.5 kilometers. And here's our delivery time, distance, and cost. And the data the site is shows the key operational metric calculated from the soft results of delivery route optimization.
Okay, so here is the implication. The first one is to reduce distance and time. The second one is the capacity compliance, and then the third one is the to improve the scheduling, and also for the last one is scalability. Next. So here is the conclusion. So optimize routing, reduce total distance and delivery time, and then all client time windows were met, proving the model's capability to handle a real constraint in urban delivery. And then even basic tools like Excel Solver can deliver effective results, proving that data-driven logistic is accessible even for micro or small enterprises. Next. So here is the recommendation. The first one is to integrate optimization. And the second one is to adopt advanced optimization techniques. And then the third one is to invest in staff training. The fourth one is to improve data collection and also for the monitoring. And also for the last one is to explore long-term and automation. And that's all from us. Thank you.